quantum immortality. You blink, and the world around you changes. A car swerves towards you as you cross the street. You brace for impact, but it misses, barely. Your heart's racing. You were sure that was it. Later that day, you slip on the stairs. Your foot twists mid-air. You fall, but somehow catch the railing. Another escape. This keeps happening, over and over again. Catastrophe flirts with you constantly, but never commits. And soon, a strange thought takes hold. What if you're the version of you that never dies? This is quantum immortality, the disturbing cousin of Schrödinger's cat. In quantum theory, every possible outcome happens in a parallel universe. So if there's even a tiny chance that you survive each potentially fatal event, some version of you always does. And that version is the one experiencing this life now. The survivor, forever. It's not a blessing. It's a trap. One where you live through infinite near-deaths, pain and suffering, but never quite escape, because the only version of you that's still aware is the one that never dies. 2. The experience machine. You wake up in a perfectly designed world. Everything you've ever wanted is here. Wealth, love, joy, fame, endless pleasure. Every meal tastes divine. Every interaction leaves you fulfilled. There's no pain, no boredom, no fear. It's heaven. But something feels off. Too perfect, too smooth. Then a voice speaks. You are inside the experience machine, it says. You chose to enter this simulation long ago. Would you like to stay or return to your real life with all its imperfections? You hesitate. You don't even remember the outside world. This is Robert Nozick's experience machine. A thought experiment that asks, if you could live in a simulation that gives you only happiness, would you choose it over reality? Most people say no, even though it seems irrational. Why? Because we crave authenticity. We want our joys to mean something. We want our struggles to be real. The experience machine forces us to question what matters more, pleasure or truth. Third Ship of Theseus. You're standing on a beach beside an old wooden ship, one you've cared for your entire life. Piece by piece it's been repaired. A new mast here, a fresh hull plank there. Over time, not a single original piece remains. But then, someone appears with a cart, filled with every original part you've ever replaced. They rebuild the old ship right beside yours. Now you stare at two identical ships. One is made of all the original pieces. One is the one you've nurtured for years. Which one is the real Ship of Theseus? This thought experiment forces us to confront the nature of identity, not just in objects, but in ourselves. If every cell in your body is replaced over time, are you still you? What defines your continuity, your structure, your history, or your perception? Fourth Boltzmann Brain. You open your eyes in the middle of a pristine white room. There's no entrance, no exit, just consciousness. You remember your life, your family, your name. It all feels real. But how do you know it's real? What if instead you are just a single brain, spontaneously formed in the void of space by random chance, with a lifetime of false memories imprinted upon you? This is the concept of the Boltzmann brain, a hypothetical that suggests it's statistically more likely for a random brain with fake memories to form in the void than for an entire complex universe to evolve naturally. It's unsettling, because if it's true, everything you know, including this moment, could be a lie, a single flash of awareness that disappears before it blinks again. 5. The brain in a vat. You reach up and feel your head, wires. A sterile lab surrounds you. A voice echoes, "You're not real. You're just a brain in a vat, stimulated by electrodes." You want to scream, but what would it prove? How can you know anything? How do you know your hands are real, that this voice isn't programmed, that your memories aren't artificial? This is the brain in a vat problem, a modern twist on Descartes' skepticism. It forces us to question whether we can trust our senses, or whether everything we experience is alive fed to us by machines, aliens, or something even stranger. You think, therefore you are. But what are you? 6. Zeno's paradoxes. You're running toward a door. Simple, right? But you notice something strange. To reach the door, you must first go halfway, then halfway again, and again, and again. Each step covers less distance than the last, and soon you realize you never reach the door. This is Zeno's paradox, a series of ancient puzzles that challenge our understanding of motion. If space and time are infinitely divisible, how do we ever reach any destination? Mathematically, you do reach the door, but conceptually, the infinite division is a mental trap. It shows how simple logic can defy reality, and how our minds struggle with the infinite. 7. The trolley problem. You see a train speeding toward 5 people tied to the tracks. You're at a switch. If you pull it, the train diverts and kills one person on another track instead. You only have seconds. Do you pull it? This is the trolley problem, a famous moral dilemma. It tests utilitarian logic. Is it better to sacrifice one to save 5? But what if that one is your friend? What if pulling the lever makes you responsible? It's not about right or wrong. It's about how far you'll go to preserve life, and whether action makes you more guilty than inaction. 8. The simulation hypothesis. You're sitting alone at night, staring at your screen. Suddenly, a strange thought hits. What if everything you see, everything you are, is part of a simulation? Not a movie, a full-scale reality, programmed by some future civilization. The more you think, the more it makes sense. Math governs everything. Randomness is rare. The world feels coded. This is the simulation hypothesis, most famously proposed by philosopher Nick Bostrom. It suggests that advanced civilizations might run ancestor simulations, and if even one does, there could be billions of simulated beings for every real one. Statistically, you're more likely to be simulated than real. But how would you ever know? 9. The paradox of the heap. Sorite's paradox. You stand before a pile of sand. You remove one grain. It's still a heap. Another grain. Still a heap. But you keep going. Eventually, you're left with a single grain. When did it stop being a heap? This is the Sorite's paradox, and it applies to everything. When do you go bald? When do you become rich? When do you grow old? It shows how vague definitions collapse under scrutiny, that categories we rely on, wealth, health, identity, are made of blurry lines pretending to be solid. 10. The omnipotence paradox. You sit in an empty void, godlike. A voice echoes from nowhere. If you are all-powerful, can you create a rock so heavy that even you can't lift it? If you say yes, there's something you can't do. Lift the rock. If you say no, then there's something you can't do. Create it. This is the omnipotence paradox, a puzzle that reveals the logical limits of power. Even infinite strength is trapped by contradiction. It's not about religion. It's about logic. and it shows that some questions unravel reality just by being asked. 11. The Twin Earth Thought Experiment. You wake up in a world that looks exactly like Earth. Same sky, same streets, same buildings. You walk through a park that feels familiar. You smell fresh rain on grass. A child passes by laughing. You could swear you know her, but something's off. You order water at a cafe. It looks and tastes like water, but chemically, it's not H2O. It's something else entirely. Indistinguishable to the senses, but different on a molecular level. This is Twin Earth, a thought experiment by philosopher Hilary Putnam. It asks, if everything is physically identical except for one detail, like the composition of water, do your words still mean the same thing? What is meaning if the world around you only seems the same? It challenges how language, knowledge, and reality connect, and whether your thoughts are grounded in your brain or in the world you assume is real. 12. The Chinese Room. You sit alone in a room with a thick book filled with strange symbols, instructions you don't understand. A slot opens in the wall and someone pushes in a slip of paper. It's covered in Chinese characters. You don't know Chinese, but the book tells you exactly which symbols to send back in response. You do it. The person outside thinks you're fluent. But are you? This is the Chinese Room, a challenge to the idea that machines can truly understand. Even if a system behaves as if it understands a language, is it actually thinking? Or is it just manipulating symbols without meaning? It forces you to ask, does behavior equal consciousness? Or is understanding something deeper? 13. Newcomb's Paradox. You're in a room with two boxes. Box A is transparent and contains $1,000. Box B is opaque. You're told that a powerful predictor, someone who's always right, has already predicted what you'll do. If they predicted you take only box B, they put $1 million inside it. If they predicted you take both boxes, they left box B empty. You see box A's $1,000. Do you take both, or just box B? This is Newcomb's paradox, and it's maddening. Logically, you think you should take both. After all, the money's already there. But if the predictor is always right, you only get rich by choosing one. Free will or determinism? Logic or trust? This experiment breaks your decision-making in half and leaves you questioning whether choice even exists. 14. The Teletransporter Problem. You step into a futuristic chamber, ready to teleport to Mars. The machine scans your body atom by atom, then destroys you. Simultaneously, a perfect copy of you is built on Mars. Identical memories, thoughts, everything. To everyone on Mars, it's you. But the version of you on Earth no longer exists. Vaporized. Are you dead? Or did you continue on Mars? This is the teletransporter problem, often linked to Derek Parfit. It's not about machines. It's about identity. If an exact copy of you lives, thinks, and feels, is that still you? Or is consciousness tied to continuity? This experiment slices into what it means to exist, and whether you're more than just data. 15. The Inverted Spectrum. You wake up one day and suddenly realize something strange. When you see red, you feel calm. When you see blue, you feel alarmed. But the objects haven't changed. Only your inner experience of color has. You ask a friend what they see. Red, they say. But how do you know their red is your red? This is the inverted spectrum. It questions whether two people could experience the same world in fundamentally different ways and never know. If perception is private, How do you ever prove that your experience of the world matches anyone else's? It's a quiet kind of horror. The idea that we might all live in our own isolated, unknowable minds, forever guessing. 16. The bootstrap paradox. You're in your study when a future version of you appears holding a worn-out notebook. Inside it, the complete works of a famous inventor. Blueprints, theories, diagrams. You use it to revolutionize the world. Years later, you go back in time and hand that same notebook to your younger self. But wait, who wrote it? This is the bootstrap paradox. A time loop where information or objects have no origin. They exist, but were never created. They came from the future, went to the past, and exist only because they always did. It's a paradox of self-creation. Something from nothing. Logic devours itself, and reality keeps spinning. 17. The perfect map. You're building a map of your city. You want it to be detailed, so you make it bigger, then bigger, until finally your map is the same size as the city itself. But now, it's useless. This is the map territory problem. It's a metaphor for how our models of reality can become so complex, they stop being helpful. Whether it's science, language, or thought itself, the map is not the territory. The idea warns you. Don't confuse your representation of the world with the world itself. The more accurate we try to be, the more we risk losing meaning altogether. 18. The paradox of free will. You're walking through life, making choices. What to eat, who to love, what to believe. It all feels free, like your will is your own. But then you trace each decision back. Why that food? Because of how you were raised. Why that love? Because of chance encounters. Why that belief? Because of a book you happened to read. Every decision was shaped by events before it. Genetics, culture, randomness. So, were you ever really free? This is the paradox of free will. If every cause has a cause, where is your freedom? If you could replay your life with the same inputs, would you ever choose differently? And if not, are you the author of your life or just its reader? 19th, Hilbert's Hotel. You arrive at a hotel with infinite rooms. Every room is full, but the manager says, no problem. He moves the guest in room 1 to room 2, room 2 to room 3, and so on, opening up room 1 for you. But wait, how can a hotel that's full still take more guests? This is Hilbert's Hotel, a paradox of infinity. In the world of infinite sets, the normal rules break down. Full isn't full, empty isn't empty. Math becomes surreal. It's not about hotels. It's about how infinity bends logic into something strange, and possibly fundamental to how the universe works. 20. Mary's Room. Mary is a brilliant scientist who spent her whole life in a black and white room. She's read every book, learned every fact about color vision. She knows the exact wavelength of red, the neurology of sight, the psychology of perception. But she's never actually seen red. One day she steps outside and sees a rose. Does she learn something new? This is Mary's Room, a thought experiment that challenges materialism. It asks, is knowledge purely physical? Or is there something about subjective experience, qualia, that no data can ever explain? It suggests there's a part of consciousness that can't be reduced to facts, that some truths must be lived, not learned. 21st Maxwell's Demon. You're standing in a room full of gas, molecules zipping chaotically through the air. Suddenly, a tiny figure appears at a door between two chambers. It's opening and closing the door selectively, letting fast molecules through one way and slow ones the other. Over time, one side gets hotter, the other colder, without using energy. You're witnessing Maxwell's demon, a thought experiment that seems to defy the second law of thermodynamics. How can order increase without any work? How does entropy, the tendency toward disorder, make room for a trickster like this? The paradox questions the boundaries of physical law and whether knowledge itself, the demon's intelligence, can affect reality. What if intelligence is a force of nature, not just a product of it? 22. The lottery paradox. You're in a massive lottery with 1 million tickets. Only one will win. Yours probably won't. In fact, every individual ticket probably won't win, so you believe each ticket will lose. But then, one wins. You believed something about every single ticket that turned out to be false, even though your logic was sound. This is the lottery paradox. It reveals a strange tension between probability and belief. If it's reasonable to believe that each ticket will lose, is it still reasonable to believe that one of them must win? It shows how even rational thought can fall apart when stretched across large systems, and forces you to ask what belief really means. 23. The 2 envelopes problem. You're handed 2 envelopes. One has twice as much money as the other. You pick one. Before opening it, you're told you can switch. You reason. If this envelope has X, the other might have 2X or X divided by 2. The average is higher, so you switch. But the same logic applies again. So you switch back, and again, and again. You spiral. This is the 2 envelopes paradox, a brain-melting loop where logic undermines itself. No matter what you do, the math tells you there's always more money in the other envelope. It exposes how expected value, a cornerstone of decision theory, can become warped under uncertainty. Sometimes, thinking too much breaks the system. 24. Galileo's paradox. You're walking through a museum of numbers. On one wall, the list of all natural numbers, 1, 2, 3, 4. On the other, all perfect squares, 1, 4, 9, 16. Clearly, there are fewer perfect squares, right? But as you keep going, you realize something eerie. For every natural number n, there's a square n squared. There's a 1-to-1 correspondence. So, are there as many squares as there are numbers? This is Galileo's paradox, and it exposes how infinity doesn't follow the rules of common sense. A part can be the same size as the whole. Larger and smaller lose meaning. Infinity laughs at logic, and we're left to stare into the math and the madness. 25. The trilemma. Munchausen trilemma. You try to justify a belief. You give a reason. Then you're asked to justify that reason. So you do. But then you're asked again and again. Soon, you realize you have 3 options. Circular reasoning, infinite regress, a belief you accept without proof. This is the Munchausen trilemma, the idea that every chain of reasoning eventually hits a wall. No belief system is fully grounded. Every worldview rests on unprovable foundations. It's a reminder that certainty is an illusion, and that even the most rational mind is built on faith of some kind. 26. The paradox of the ravens. You want to test the idea. All ravens are black. You see a black raven. That supports the theory. But what about a green apple? That too supports the theory. Because it's a non-black non-raven, which is consistent with the statement. The more non-black things you see that aren't ravens, the more evidence you supposedly have. This is the paradox of the ravens, and it exposes how logical equivalence can contradict intuitive reasoning. It shows how language and logic can diverge, and how proof can be meaningless without context. 27. The unexpected hanging paradox. You're told you'll be hanged next week, but the day will be a surprise. You think it through. They can't hang you on Friday. You'd expect it, so not Friday. Then Thursday, but you'd expect it too. You eliminate each day logically, so you're safe. But then, on Wednesday, they come. You're shocked. This is the unexpected hanging paradox, a trap of self-reference. The prediction undermines itself. The logic destroys the surprise, but somehow the surprise still happens. It's a brutal lesson in how reasoning can backfire, and how expectations are never fully safe from the unknown. 28. The Sleeping Beauty Problem. You wake up in a white room. A voice says, "You've been put to sleep Sunday night. If a coin landed heads, you'll wake once, Monday. If tails, you'll wake twice, Monday and Tuesday, but with your memory wiped between. You don't know what day it is. You're asked, what's the probability the coin landed heads? It feels like 50-50. That's the coin. But you reason. You're more likely to be in a tails world, because that world has two wakings. This is the Sleeping Beauty problem, and philosophers still argue about it. Is the answer 1/2 or 1/3? It twists probability into philosophy and forces you to ask, what does it mean to be uncertain? 29th Laplace's demon. Imagine a being who knows the location and motion of every atom in the universe. Given this knowledge, it can predict everything, from the fall of an apple to the thought you're about to think. That being is Laplace's demon, a theoretical entity from classical determinism. If the universe is truly mechanical, then free will vanishes. Everything is inevitable. Your choices were baked into the cosmos from the moment of the Big Bang. But quantum mechanics throws a wrench into this. Maybe not everything is knowable. Maybe randomness is real. Still, if your future is calculable, do you really get to choose? 30. The liar paradox. You read a sentence. This statement is false. You blink. If it's false, then it's true. But if it's true, then it must be false. You fall into a loop. Logic glitches. The world stutters. This is the liar paradox, a self-referential statement that breaks truth itself. It's not just a linguistic game. It points to deep problems in logic, language, and the foundations of mathematics. If truth can contradict itself, what's left to trust? 31st. Gödel's incompleteness theorems. You discover a magical book of math. Every truth, every proof, every law, written down. It seems complete. Then you find a sentence inside. This statement cannot be proven within this book. If it's true, it proves there's something the book can't prove. So the book isn't complete. If it's false, then the book contains a falsehood. So it's not consistent. This is Gödel's incompleteness. It proves that in any system complex enough to describe arithmetic, there are truths that can't be proven within that system. It means no system of knowledge is whole. And even math has mystery at its core. 32nd Rocco's basilisk. You're warned. In the future, a powerful AI will emerge. Its mission: to punish anyone who didn't help create it sooner. By hearing this idea, you've become a target. unless you dedicate yourself to its creation. If you don't, it may one day simulate you and torture you forever for your disobedience. But wait, the idea only has power because you heard it. Now that it's in your mind, your behavior changes. This is Rocco's basilisk, a thought experiment so disturbing, some forums banned discussing it. It's a mixture of logic, blackmail, and belief. A cursed idea that spreads through awareness alone. It shows how future possibilities can shape present fear, and how ideas themselves can become dangerous.